皆さん、はじめまして。私は DAOと Tween という新しいの Android デベロッパーです。Android の開発者を11年ぐらいしています。Android と Kotlin の Google デベロッパーエキスパートです。今、Trello というアプリに取り組んでいます。今日はJetpack Compose のアニメーションについてお話しします。それでは始めます。Hi, I'm Huyen Tuet Dao. I am an Android developer at Atlassian. I've been working as an Android engineer for 11 years. I'm an Android and Kotlin Google developer expert, and I'm currently working on an Android app called Trello. Today, I'm going to be talking to you about the Jetpack Compose animations. So let's get started. So I kind of wanted to just talk briefly about how are Compose animations different than the traditional Android view animations. So Android view animations are generally, I think, historically considered to be a little difficult to work with, and mostly because, we've had Android development for over 10 years now, and in that course, the Android animation ecosystem has kind of organically grown from, Android 1.0 through experiencing different, changes like material design, motion design, different platform capabilities. And we basically have an animation ecosystem that has a lot of animation APIs that make it a little bit hard to kind of understand what all the APIs do at the same time, and also more importantly, to know which ones to use in what situations. So Jetpack Compose and its animations are a little different in a few ways. Number one, Kotlin. Jetpack Compose being completely based in Kotlin means that its animations are also based in Kotlin. And so what's interesting is that its lowest level APIs are actually backed by coroutines. And so challenges with coroutines can also find their way in animations if you use the lowest level APIs. And, there's a mix. Some of the animations are actually composables, some animations are actually extension functions, and some are both. But overall, because of the basis in Kotlin, we have actually really nice fluent APIs that utilize Kotlin syntax, and, we have a lot of nice little DSL structures. But really what's important about Jetpack Compose animation is Jetpack Compose itself. This unidirectional data flow type architecture where we have our views as observers to reactive streams of data and state. And we want to just trigger recomposition, redrawing, and animations, which are also basically types of redrawing and recompositions from these state changes. And we want to make sure that they coordinate with the other parts of Jetpack Compose composition, or Jetpack composition, or Jetpack Compose composition. So Jetpack Compose being kind of this greenfield project, this kind of clean slate, means that there are some kind of nice things about the animation API in that it's a bit more coherent. Instead of 8 APIs, we more or less have one. And I think what the really neat thing is that Android development has been around for over 10 years now. And the Android team and us as an Android community have developed, discovered, experienced kind of like the best practices, best defaults, best ways of making animation beautiful. And what's cool is that if you look inside of Jetpack Compose, a lot of these best practices, a lot of these best values are default, are available in the API itself. And we'll see that in just a little bit. So for the purposes of this talk about animation, I have an example application that has several different types of animations in it. And I had first wanted to kind of do a one-to-one comparison on Android View animations and Jetpack Compose animations. But because Jetpack Compose animation Jetpack Compose in general is so different from Android Views, that got a little bit difficult. But we'll start off at the low level where we can kind of see more parallels. My first example here are a couple of clocks that are drawn using Canvas drawing, both View version and a Compose version, and both are Canvas. And the animation comes into play with drawing the second hand and the minute hand, although they're moving a bit faster than that. So basically what I'm animating for both clocks is the angle at which I draw each of the hands. And if I go over here to Android Studio and look at my Android view version, I can see down here a lot of kind of very familiar canvas drawing functions that are doing the work of drawing my clock. And up here is where the actual animation takes place. So value animators are kind of some of the basic building blocks of view animations. They're basically little, as the documentation says, engines that drive, a value from an initial value to a target value over a certain period of time. And there might be some kind of easing interpolator added that describes how that value changes over time. So here I have two value animators animating floats. I have update listeners because as the value changes, I need to be able to respond to it. And in this case, I do by invalidating my view, which will call onDrawAgain, which means I get to draw my clock face with the new angle for each of the hands. And this is in the view initialization. And I basically am doing very simple animation. I'm basically starting the hands moving as soon as the view renders. So as soon as I'm done setting up my value animator, I call start. And that's it. And way down here, you can see where, as I'm drawing, I'm pulling out the current value of the animator, the animated value, and using that to draw the hands of my clock. So if I go over to my Compose version, which is all the way up here, there are some things that look similar with the canvas drawing, but here I have something a little bit different. I have the basic building block, or one of the basic building blocks of Compose animations, and that's the animatable. Animatable, similar to value animator, is a very simple class. It's a value holder. But there are methods that you can call on this value holder to drive it to other values. And you can use that driving, that interpolation, that animation from one initial value to a target value to be the source of change for recomposition and composition in Compose. So just to clarify what I'm talking about, if I go all the way down here, I see all my draw commands, and I see these two launched effects. So what's interesting about Animatables is that it doesn't have a start function. It doesn't have an update listener. What I can do with it is call Animate2. So when I declared Animatable, I gave it an initial value. And in order to say, hey, Animatable, I want you to interpolate to a new value, I call this Animate2 method. So Animate2 is a suspend function, and it needs to be called within a proper coroutine scope. And I'm doing that by using launched effect, which is a composable. This composable basically will enter the composition and basically start a coroutine and execute the code in this block inside of that coroutine. Now, launched effect can rerun this block based on any changes to the value that you give it in its parameters. And what happens here is that when this block gets called, I call Animate2 on my animatable, and it basically says, okay, I'm going to start moving this value that I'm holding to that target value. And just kind of like value animators, I can do a little bit of customization. I can set a duration over which the value will move from an initial state to the target state. I can specify some easing, interpolating, and that's pretty much it. Now, I mentioned that this launched effect will actually rerun this block based on this key value, and I put in unit, which is a constant value. So because I really only want this to run on initialization, or at least in Compose World on initial composition, I pass it a constant value. So this will never change, and so this block will never be rerun. If I did have a kind of changing value in here, .animate2 would get called every time this key changes. And when you call Animate2 on an animatable, if there's an existing animation, it will get canceled. And then it will go from whatever value is in the animatable at that moment and then drive to the new target. And that's pretty much it. And this is how I do the kind of fire and forget single launch animation that I did with a clock. Now this is pretty low level. Again, we're kind of at coroutine level where we have scopes to worry about and suspend functions. What about something a little bit higher level and nicer? So I mentioned that what's really nice about Compose is that it's kind of an aggregation of good practices and good defaults. And kind of part of that is taking commonly done tasks in Android animation and making them easy. So what do we do a lot in Android animations? We show and hide things. So this is a Compose built screen where I'm taking this image and just showing it and hiding it. I'm doing a little bit more. I'm kind of sliding it in and out while I'm fading it in and out, but that's pretty much it. So how did I do this? So if I look into my animated visibility example, I'm implementing this using the Animated Visibility Composable. So Animated Visibility Composable is one of those kind of higher level APIs, but it's still driven by state like any other composition, any other kind of rendering in Jetpack Compose. So I have here this value shown. Now, if I kind of go back up here into my UI, I've actually kind of, this is kind of an extracted version of it, but if I go kind of in the more basic example where my content is kind of in line with the rest of my UI, I have here this Boolean state called shown. And as I kind of turn this switch on and off, it's changing this state. And this state gets propagated. These state changes get propagated to animated visibility. There's a lot of long words in this talk. So animated visibility is listening for changes to shown. And, if visible is true, then it actually renders the composables that are inside of its content block. And if it's false, it doesn't. Now, it doesn't just kind of say, okay, I'm going to draw the content or not draw the content. It can also specify how that content gets hidden and shown. So in this, I actually have a little bit of customization. I can customize a transition by basically specifying what's commonly called animation specs, animation specifications. They're basically configurations. And I can do common things like set a duration on certain things. But there's a little bit more than going on here than I originally had with my old value animators. So I have an enter and exit transition that I'm kind of overriding. And for the enter transition, I'm saying slide in the content vertically and fade it in. And not only that, I'm saying the fade in has a certain keyframe where I want the alpha to be 1 already at 50 milliseconds. The exit's a little more simple. I'm saying slide out the content and fade it out. Now you can see the kind of very Kotlin-ness of this API. You can see some operator overloading with a plus. You can see a little DSL here with the keyframes. And yeah, you can see that a lot of it is kind of just encapsulated. And what's, I think, really cool about the way that animated visibility works is that if you think about view animation APIs, a lot of times the layout and the view definitions are quite separate from the code that animates it. You might be doing a value animator in code. You might be using transition and transition manager, either from XML files or from code again. And they tend to get a little bit separate. It can be hard to tell what in a layout is moving and how it's moving by looking at either the transition code or the layout code in isolation. Whereas here, animated visibility is a composable, just like the views, just like the content that it's animating. And I can see both how the state changes and how the content is rendered, or rather when it's rendered, and also how it's rendering, both in and out. And I think that's pretty neat. And again, there's a lot of customization here. And in fact, these individual transitions can be further customized with their own animation specs. And if we look in here, we actually see by default, we have something called Spring. So again, this is one of those kind of good practices and good defaults in Jetpack Compose animation. So Spring is actually a Spring animation, just like you would see in a physics-based animation APIs that we already have. And if you've seen that example of the little droid on a spring bouncing around, you might think, okay, well, why is there a spring in here? Well, if you've watched, several of the talks from some of the, animation-centric folks in the Android team, like Doris Liu and Nick Butcher, they've actually in recent years recommended that you use the spring animation to move, widgets along a screen. Because these animations are physics-based, it kind of lends a reality, a tactile, physics to the movement to make it feel a little more real. Because things in real life don't change directions quickly. They don't turn at weird angles. They have velocity. They have momentum. And the physics-based animations kind of blend that to views. And just for a quick example, here in my animation just to show what that would look like. We have here an icon, and I'm using the view, the kind of view-based spring animations to make it kind of bounce around. And as you can see, it feels like it has weight. It feels like it's a physical object more or less in the space. But, looking at the API itself, it's a lot. There's a lot of boilerplate. It's just not as fun to use. And again, it's quite separate, the spring animation, from the layout, from the view in which I kind of defined, in which it's going to be kind of acting on. Now, again, going back to the enter-exit transition with this really nice spring method, all of the kind of configurations, the stiffness of the spring, like how bouncy it is, are all just really nicely named parameters in this API. And it's just some function that I can call, as I'm defining this transition in its animation spec. So again, good defaults and good practices and a good Fluent API that's integrated and works well and kind of is able to kind of be read and understood in the context of the UI that it's acting on. So I wanted to kind of go back a little bit lower and talk about animate state. Well, not low to where animatable was, but I wanted to talk about animate as state, because the animate as state composables are probably the most common thing you see when you start learning about compose animation and start seeing examples. So if I look back at the kind of animatable that I was using inside of my kind of clock composables, there was a lot that I was specifying by hand. Duration, the target value, the initial value. I had to go through launched effect to actually kind of start it. And I don't have to do that really, and I shouldn't normally be using such a low-level API. What I can do is use the animate as state composables. So there's several of these for different value types, for DP, for float, for int, for color even. And basically, if I look at this example, which I'm going to show you here. So I have an image and I want to animate it kind of along two properties, two vectors. I have a saturation animation more or less. Basically, I'm turning the image from color to black and white. And then I have a size animation where I'm kind of having the width of the view fill the screen and then not so much and back and forth. And you might be able to notice there's a little bit of a spring animation in there. So to do that, I'm using animate as state. So I have two Boolean flags, two Boolean states again, off and on for my black and white and my full size. So I have remember composables holding on to these Booleans. Now, changes in these Booleans are actually going to drive my animations. So my saturation animation is, again, listening to that black and white flag and saying if it's black and white, then the saturation would be 0. If not, it should be 1. Now, this is an animation, so rather than saying explicitly, okay, set it to 0 now, it's going to say, okay, animate towards 0. And similarly for the width, I have a max width and a min width, and depending on what the Boolean value of that full size is, I'm saying, okay, animate towards the min width or animate towards the max width. Now, these animations themselves generate a state, generate a animated value. And that animated value is going to be observed by this image composable down here and goes into this color filter, which does the black and white effect, and also the width on this modifier, which controls the size. And that's pretty much it. As you can see here, I've kind of adjusted the spring a little bit, which I can do through this animation spec, or I can actually use a tween, which is a little bit more of the kind of simple, more, specific duration and initial to target being interpolated to in that duration. But again, there's consistency and coherency in the API, same kind of parameters, same syntax, same style as other kinds of animation APIs. And there's no specific handling of a update listener. There's no starting and stopping. Everything here, just like the rest of Compose, is based off of changes to these parameters, changes to state that are driven somewhere else and that just come down the line. And this food card knows when to recompose and be black and white, be full width or be min width, just based on these state changes. And these animations will take the job of animating the state from one value to another smoothly and with whatever springs or tweens that I want. So just to finish off, I want to talk about a couple of more complex composables. So the first is animated content. So my entire application with this kind of list to detail view style is done with animated content. So there's a state here. There's a selected example, which is basically the state of this entire application. Now, animated content, like a lot of other things with Jetpack Compose, is based off of changes in state. So if I go to my actual launch screen, I can see animated content here. So it's actually a composable container that specifies both some set of content that should be rendered conditionally on a certain state. So animated content takes a state, or rather listens to some value as state. In here, it's example. So the example is an enum, and I'm changing it as I'm making selections on that screen. And so animated content is observing my changes to the example that I'm selecting. And down here in this content block, I'm saying, okay, if I have some selection, and it's not null, or not none rather, I'm going to render some example content. If I don't have a selection, then I'm just going to render my example list. So that is pairing a state with the content that should render for that state. Now, with animated content, the idea is that you're basically swapping content in and out, which means that you have some transition between the old content and the new content. And in order to configure those transitions, you have this transition spec. So in transition spec, you have access to, again, that state to which animated content is listening. And here I'm saying, okay, if the incoming state, if my target state is not none, if I have a selection, then I want to slide in that new content. And at the same time, I want to fade out the old content. Now, this with is an infix based function that is basically pairing an enter and an exit transition. And that's what you need to return from this block. Now, if I'm in the opposite situation where I'm actually on a example detail screen and I want to move back to my example list, then I say, okay, the new content coming in is my example list, so fade it in, and at the same time, slide out the old content. And that's how I do my main example. And finally, we have kind of something that we haven't quite touched on, and is that how do we kind of do something like animator set, where we can kind of group together and coordinate several child animations at once. So this isn't actually an animated visibility composable. This is 3 different animations going on at once. So when this is being hidden and shown, the alpha of the clock itself is changing between 0 and 1. The elevation of the card is actually raising and lowering. And then the container that holds the card itself is kind of sliding up and down, left and right. Now I have multiple animations and multiple children. And I'm able to do that. I'm able to coordinate these different animations on different children using update transition. So you can think of update transition as like an animation set. It's basically a composable that is going to listen for state changes, and it will coordinate several child animations based on the changes that it observes on that state. So I have some target state. Here it's card shown, which is driven by that switch again. And transition will basically coordinate any child animations based on changes that it observes to card shown. So to add child animations, I can use these animate float and animate DP methods, which look a lot like animate a state. And they more or less are. They're basically ways of driving a change from a certain value to a target value. Just that the state that they kind of key off of is the same state that we've already passed to update transition. So basically we specify everything else. We specify, how we want that to animate. And we do that the same for the content alpha, the card elevation. Now we don't just do animate as state type animations, but we can also add a high level thing like an animated visibility that again will use the same kind of observed stream of off or on, show or hide, and use that to drive the display of this example card. So that's the whole card in and of itself. And I've customized it with different transitions like I did before. But now this animated visibility is coordinated and keying off of the same state changes as those other 2 animations are. So that's Jetpack Compose animations. I think that there's a lot to love about them, but there's a couple caveats that I want to talk about. First is, again, coroutines. Coroutines are difficult. There are ways when you're working in the lower level APIs to trip yourself up, just as you might with coroutines in general. So that's just something to be aware of. And just in general, try to use the higher level APIs anyway. Also, the Compose animation API system is not complete. In case you are looking for something like motion layout, where you want something with choreography or user input driven or seekable animations, though it is coming. And also, the animation APIs are still a work in progress. A lot of these APIs that I showed you are experimental, so use with caution. But I think overall, as we're kind of moving to Jetpack Compose as our UI toolkit, the animations API is definitely something worth looking into and is a really good evolution from the previous organic Android View animation ecosystem to this kind of new UDF style UI development that we're doing now. So I really hope that you try it out and enjoy. 皆さん、ご清聴ありがとうございました。またお会いしましょう。Thank you very much.
ドロイド会議2021チャンネル登録をお願いいたします。